This documentary explains why Starlink satellites are important from a scientific and technological perspective. A recent launch added 25 Starlink satellites into low Earth orbit. These satellites are part of a large communication network designed to provide global internet coverage using space-based technology. Starlink is not a Moon or Mars mission. It is an Earth orbit system. However, its technology directly supports future space missions by improving communication, launch experience, and space operations. A Starlink satellite is a flat, compact spacecraft operating in low Earth orbit, typically between 300 and 550 kilometers above the surface. Each satellite weighs around 260 to 300 kilograms and is powered by a solar array. The satellite uses phased array antennas for data transmission, krypton-based ion thrusters for orbital control, autonomous navigation systems to avoid collisions. These systems allow the satellite to adjust its orbit, maintain spacing, and safely deorbit at the end of its life. Traditional communication satellites orbit at 36,000 kilometers. This short distance reduces latency significantly. Low latency means faster data transfer, real-time communication, reliable video, voice, and emergency services. This is the main scientific reason Starlink performs better than older satellite internet systems. The recently launched 25 Starlink satellites were added to increase network capacity. Their purpose is not exploration, but network optimization. They are used to fill coverage gaps, increase bandwidth, reduce congestion for existing users, improve reliability during peak usage. Each launch strengthens the constellation by making the network denser and more stable. Starlink satellites communicate with user terminals on the ground and with ground stations connected to the global internet. Newer satellites also use laser intersatellite links. Laser links allow data transfer directly between satellites, reduce dependence on ground stations, coverage over oceans, and remote regions. This creates a space-based mesh network that moves data efficiently across the planet. Starlink provides valuable scientific data about atmospheric drag in low Earth orbit, space traffic management, autonomous satellite control, large-scale constellation behavior. This data helps engineers and scientists design safer spacecraft and manage crowded orbital environments. Starlink satellites do not travel to the Moon or Mars. However, they indirectly support these missions. Starlink funds Starship development, improves launch operations communication, tests reusable launch systems, advances space navigation and autonomy. The experience gained from deploying thousands of satellites helps SpaceX prepare for deep space missions. Starlink satellites are designed to safely deorbit after their mission life. When retired, they re-enter Earth's atmosphere and burn up completely.
Stage 1 MTSSC.
Stage 1, entry burn startup. Entry burn shutdown. Stage 1 transonic.
Stage 2 MTS has safed.
Stage 1 landing burn.
Stage 2 terminal guidance.
Landing leg deployed. Stage 1 landing confirmed.